In this particular lesson, what we're actually going to cover is we're going to talk about organic compounds. Like we just talked about inorganic compounds, we're going to focus specifically on our 4 classes of organic compounds. So, as we previously stated, the distinguishing feature for organic compounds is that they contain carbon, and your book also indicates that they contain hydrogen. Although I want you guys to really focus on this carbon factor, because really containing carbon is the big distinguishing feature for organic compounds. We talked about the fact that they're typically larger than the inorganic molecules, and that's because if they contain carbon, carbon typically forms 4 bonds. And that means that all of their carbons are able to form those 4 bonds and therefore more likely to join with more atoms and become a larger molecule. Some of the organic compounds are going to be able to dissolve in water, but for most of them they're going to dissolve in organic fluids. For example, we previously said ether. And our examples, right, these are our 4 classes of organic compounds, and these 4 classes are carbs, lipids, proteins, and nucleic acids. So, the first one that we're going to talk about specifically is carbohydrates. We should know that carbohydrates are composed of sugar, so everything that's composed of sugar is considered a carbohydrate. That means that carbs are not only those breads, pastas, rice, grains, but we're also talking about fruits, and we're also talking about vegetables as well, right? Carbohydrates contain carbon, hydrogen, and oxygen, and typically it's in a N to 2N to 1, a 1 to 2 to 1 ratio. More specifically is really focusing on that hydrogen to oxygen, ratio, guys, sorry about that. Hydrogen to oxygen ratio of 2 to 1. All right, and really recognizing that that 2 to 1 occurs and not paying quite so much attention to whether carbon matches with oxygen. Carbohydrates are an immediate source of energy as well as a stored source of energy. Right? We know that carbohydrates are going to give us more bang for the buck. That's what I typically tell you guys. They're going to be our best energy source, which makes a lot of sense if you think about what you eat when you need lots of energy. Carbohydrates are water soluble, so they are going to dissolve in water. And we use 3 different words when we classify or group our carbohydrates: monosaccharides, disaccharides, and polysaccharides. And really, if we take these words and we split them, right, we can, we can take them literally, and we know that mono is referring to 1, di is referring to 2, poly is referring to many, and when we say saccharides, sugar. I want you guys to think saccharin. I want you guys to think about saccharin as in like artificial sweetener. Right? So saccharides, we're really talking about sugar. So here what we have as an example, I hope that you can actually see that this is glucose. Right? So what we have up here is glucose. See, each of these little angles here is actually going to be a carbon. So what we end up having is C6H12O6. Amylose, notice ose, glucose, right? That's our ending for carbohydrates. All right, so we've got 2 versus many, a chain. So when we talk about monosaccharides, these are our simple sugars, our simple carbohydrates. Typically 3 to 7 carbon atoms in a monosaccharide because it's going to be one single one alone. They can be in chains, which would mean that the carbons would be arranged, just as it says, in a chain, or they can be organized into a ring, which would mean that the carbons are organized together and bonded together in a ring. Glucose, fructose, galactose, ribose, deoxyribose, these are all examples of monosaccharides. And like I said, here's our example of a chain, and here's our example of the ring. The very interesting thing is that if we look, C1, 2, 3, 4, 5, 6, we've got C6, H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, H12, and O, 1, 2, 3, 4, 5, 6. So we should know that that's glucose. However, if we look down here, we've got C, 1, 2, 3, 4, 5, 6, C6, H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, H12, O, 1, 2, 3, 4, 5, 6. This is also glucose, two different forms of glucose. This is actually what we refer to as being isomers, right? So disaccharides are going to be when we combine those two monosaccharides. So di meaning two, so two monosaccharides get combined together, and this is formed by something called dehydration. Dehydration synthesis, all right, so dehydration, we're talking about remove water, and to synthesize means to make. So we're removing water to make something. And what we are doing is we're removing water to build that larger molecule. So here's that example of dehydration synthesis. We've got our one molecule and our other molecule, our two monosaccharides, and what's actually going to happen is that we're going to have that hydrogen join with this oxygen and hydrogen, so we're going to get a water, and what's going to be left over is the one little oxygen alone that's going to form that bond. So technically, a water is left over in dehydration synthesis. Polysaccharides are going to be our complex carbs. They're going to be many sugars linked together. So for example, we've got cellulose is a particular type, and cellulose is in plants. Interesting thing about cellulose is that we can't digest cellulose. We don't have the proper enzymes to break it down. So this is actually a source of dietary fiber for us. Starch, we should know, also is in plants. All right, that one shouldn't be very unfamiliar. We should know starch pretty well. We can digest starch, right? And this is something that's going to be, typically in potatoes and other things that we eat. Glycogen is actually a polysaccharide that we find in animals. And it's a stored polysaccharide in animals. So it's kind of like those extra sugars, those extra carbs get stored as this glycogen molecule. Sometimes people talk about sugars being converted into fats, and not actually the case. What actually happens is those sugars get stored in this glycogen form. All right, picture here of that polysaccharide. You can see our many sugars bonded together.